Welcome to this video where we will be looking at our Euclidean geometry again for grade 10, and we are consolidating all the knowledge we know and looking at a few questions and applying what we know in answering the questions of Euclidean. Alright, we'll start with this. In the diagram, ABCD is a rhombus. Quickly, your mind should start racing through the properties of a rhombus, alright? Having diagonals AC and BD intersecting in O. Okay, ADO is 36,87 degrees and DO is 8. Okay, 8.1.1. Write down the sizes. Let me have my pen. Alright, 8.1.1. Write down the sizes of the following angles CDO. Alright, we know about rhombus that the diagonals bisect the angles. Alright, so automatically this angle and this angle should be equal. So CDO equals to 36,87 degrees. Alright, we know that the diagonals bisect the angles of rhombus. Number 2, 8.1.2 AOD. Alright, we know that the diagonals bisect and are perpendicular to each other. So AOD must be equal to 90 degrees. The diagonals, alright, are they bisect and are perpendicular. Alright, diagonals are perpendicular. 8.2. Calculate the length of AO. Calculate the length of AO. Alright, so what we see there is a right angle triangle, okay, and this side becomes my opposite. This side is the hypotenuse and this side is the adjacent. Remember that the 90 degrees there, which means we can use our trig ratio. Opposite and tan. Can we then say that tan 36,87 will be opposite over the adjacent DO? So we can then have that tan 36,87. We don't know our A. Do we know our AO? That's what we're looking for. And our DO is 8. So AO is simply 8 multiplied by 10, that is 6,87. Alright, let's quickly borrow a calculator. 8, 10, 36,87, and our answer is 6. Alright, now 8.3. If E is a midpoint on AB, okay, let me claim this too so we can construct, because I see some statement here that might need us to construct. Alright, I need a ruler. Oh, let's use that. Good. Now, if E is the midpoint of AB, E, so what you can do is you can construct something there, alright, and then we can call that point E. Good. If E is the midpoint of AB such that OE is parallel to DA, OE is parallel to DA. Okay, calculate the length of OE. Alright, calculate the length of OE. Oh, I see something here. We are told that E is the midpoint. Look at what I see. Look at what I see. Alright, I see a triangle . Do you see a triangle there such that AOE is parallel to AD, and this is the midpoint. This and this are equal because E is the midpoint, and then this line, and I am actually seeing a midpoint theorem. Okay, alright, so for us to get OE, we know that OE therefore will be the half of AD. Can we then get AD? Do we have AO? Yes, we have AO as 6. Oh, so if I get AD, then AD would be double of OE based on our midpoint theorem. So let's calculate AD quickly. AD squared. Remember, it's still a right angle triangle there. Alright, this is the theorem of Pythagoras. So my AD equals to 10. Alright, the square root of 100. Good. Now, since AE equals to EB, AE equals to EB, we are told E is a point on, or we are told that E is a point on AB, right? Good. E is a point on AB. Let me claim this first. E is a point on AB such that OE is parallel to AD. And we know that, remember, D is the midpoint of DB because diagonals bisect each other. Alright, so we can then say AE is equal to EB, which is the converse of our midpoint theorem. Converse of midpoint theorem. I hope that makes sense. Alright, then OE, that's what we're looking for. We're looking for OE is going to be half of what? AD. And OE will be 5 what? Centimeters. Let's just write that on the side. So we are basically using our, sometimes you need to just construct so that you can then see. Go back to the video on midpoint theorem and check what the converse is. Alright, since this and this are equal and this are parallel, it therefore means that AE is equal to EB, converse of midpoint theorem. Again, BO and DO are equal. OE is parallel to AD. It means that AE therefore is equal to EB, converse of midpoint theorem. I hope that makes sense. Let's go to the next one. Alright, we have in the diagram below, D is the midpoint. Okay, D is the midpoint of ABC. Let's find ABC quickly. Alright, I found it. There's so many lines. Alright, E is the midpoint of AC, and DE is produced to F. DE is produced to F. Okay, such that DE is equal to EF. Alright, and CF is parallel to BA. So many lines, so you've got to look for them. Okay, write down a reason why triangle ADE. Let's try to color code this triangle. Triangle ADE. Triangle ADE. Alright. Now I want the blue so that I maintain my colors. It's congruent to triangle CFE. Alright, let me use a different color here. Congruent to triangle C, and you know how to prove your congruency. Either side, 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 side angle, side. Alright, side, side angle. You need to remember those concepts. Okay, let's see. Write down a reason why they are equal. Do you notice that this side is equal to that side? right? This angle is equal to the, this side is also equal to that side. And this angle here is equal to this angle, vertically opposite angle. So I'm looking at the side, the angle, and the side. So I can simply write 911. Okay, 911 sounds like me calling an emergency number. Reason would be side, angle, side. We have two sides and an included angle. That's the reason. Right, 9.1.2. Write down a reason why DBCF is a parallelogram. DBCF. Okay, I think for simplicity, let's clean this. DB C and F. All right. Why is it a parallelogram? We know the conditions for parallelogram, right? We know that one pair of opposite sides must be parallel and equal. Okay, let's see. Then let me cover the lines. What do you notice here? Let's check something here. Already, we are given that those are parallel. Okay, those are parallel, and we also know, check this, I want you to check this. If AD is congruent to, if triangle ABC, check this, let me just write this. We said triangle ADE, alright, is congruent to triangle CFE. It means that then line AD should be equal to CF. Alright, is that okay? Line AD equal to CF. But when that line AD is equal to DB, given, line AD is equal to DB, which is given. And the same line AD is equal to CF. Check, AD equals to CF, AD equals to DB. Therefore, can we then say that CF is equal to DB? CF is equal to DB. Now look at my signs. Write down a reason why DB CF is a parallelogram. Check. DB now, we have proven that CF is equal to DB and DB is also parallel to CF. That's given. So what is the reason? 9.1.2. Alright, I'm sure it's making sense to you there. 9.1.2. What is the reason? We have one pair of opposite side. Alright, one pair of opposite sides are equal and parallel. That's what you want to prove, and that's your answer. One pair of opposite sides equal and parallel. 9.1.3. Hence, prove the theorem which says that DE, where's DE again? DE is half of BC. Oh, I see again that this examiner is bringing in midpoint theorem. Alright, let's see. We want to prove that this, remember we have already proven that this whole thing D, F, B, C is a parallelogram. It means this line is now parallel to that line. Alright, that's what we've proven. Okay, and we are also given that the side is equal to that side. I hope it makes sense. Again, we are given that this side, so basically that is a midpoint theorem. Okay, definitely DF is going to be half, DE, alright, is going to be half of BC. But again, we know that DE is half of what? Given that DE is half of DF. Let's start from there, because I want BC. Alright, we want to prove this. Okay, so let's start by saying DE is half of what? DF. I hope that makes sense. Alright, and our DF is actually equal to BC. DF is equal to BC. Opposite what? Sides of parallelogram. What then do we have? DE is half. Instead of writing DF here, can I write BC? Yes. Alright, so basically we are trying to prove, hence prove the theorem. Alright, we are trying to prove the theorem. So we won't use a theorem you are proving. So don't just say midpoint theorem. No, prove the theorem. Okay, that's what the examiner meant. You prove the theorem. Right. We prove the theorem. So you need to prove the midpoint theorem there. Let's go to the next one. In the diagram below, PQRS is a parallelogram having diagonals PR and QS. Diagonals PR and QS. Where is Q? Okay, PQ, PQR, S. Alright, diagonals PR and QS. Okay, B is the midpoint on PQ. Alright, that's point B there. Such that SBA and RQA are straight lines, and SB is equal to BA. There's so many lines. SB is equal to BA. Alright, prove that SP is equal to QA. Prove that SP is equal to QA. Prove that SP, let me do this, let me color code. Prove that SP is equal to QA. Alright, let's go check again. We're given that PQRS is a parallelogram. Okay, PQRS. One of the things we know is we have the opposite sides to be parallel. Okay, we're not sure of the equality yet, but we also know that the diagonals intersect at M. Alright, beautiful. B is the midpoint. Lovely. Let's check something. We want to prove that those two red lines are then equal. Okay, let's try to work around to prove that this one here is equal to this. Let me have a black. Alright, we're looking at 4 marks there. In triangle, let's look at triangle SAR. Triangle SAR. In triangle SAR, will that make sense? Triangle SAR, let's see something here. Let's look at this triangle. Alright, why am I looking at that triangle? Why am I looking at that triangle? Remember, we are given that SB is equal to SA. You know what, guys? Let's do this. Let's cut out that triangle. I have B, I have S, I have A. I'm given that. Okay. I have this line here parallel to that. Okay. Automatically, that gives me that QA will be equal to QR, okay, which is the converse of our midpoint what theorem. Are we okay there? So already we have this now equal to that. But we are given that SPQRS is a parallelogram. Opposite sides of a parallelogram should be equal. So do you see what we have done? We have now proven that SP is equal to QA. It's quite a complex process, but you've got to learn to see it. This will take a bit of your time. Alright, so I hope me bringing out that triangle makes a lot of sense. We want to prove that this is equal to that, but already we know that this line is equal to this line. Alright, so whenever you see these things, try to find two parallel lines and a triangle. Alright, so that's my triangle there, and I have two parallel lines. Okay, so let's put down our answer step by step. 9.2.1. In triangle SAR, SB is equal to SA. That is given. Now QR will therefore be equal to QA. We said that is the converse of midpoint theorem. What else then did we come up with? Then went back to our parallelogram, right? And we said QR is equal to SP. Alright? Those are opposite sides of PAM are equal. Therefore, do you see that both of them are equal to QR? Therefore, we can say SP is equal to QA. Alright, 9.2.2. Proof that SPAQ is a parallelogram. SPAQ. Let me erase this. SPAQ. SPAQ. Oh, by the way, remember that this line is already, we're told that it's parallel to this line. Alright? Because of this. And we have just proven that that is equal to that. So that's a continuation there. Alright? So SP is equal to QA. That has been proven. And SP is parallel to QA. That is given. Therefore, SPAQ is a parallelogram. And what's the reason? One pair of sides equal and parallel. One pair of sides are equal and parallel. Alright. Prove that. Let's clone this page to have space. Alright. Prove that. Let me clean all of this. Let's clean quickly. Alright, now we want to prove that AR equals to 4MB. AR equals to 4MB. 9.2.3. Where's AR? Let's go look for AR again. Where's A? AR equals to 4MB. Alright, although there's no line here. Alright. Let's see. Now, what do we know about M? We're told something about M. Were we told anything about M? I think we were. PQ and QS intersect in M. Alright. And that B is the midpoint. Alright, we're told that M is a point of intersection. Okay. PR. Where's my PR? Good. Alright. What else do we know about M? Oh, look at this. This is a parallelogram. And what do we know about a parallelogram? The diagonals bisect each other. Oops. So M is the midpoint of PR. Let's first write that down. M is the midpoint of PR. That's one we know. Alright, M is the midpoint of PR. Okay. And we are given as well, alright, B is the midpoint of PQ. Or we can actually prove that using our parallelogram, that B is the midpoint of PQ. Do you know why? because if we consider the other parallelogram, all right, diagonals also bisect. So look at what we have now. Let's clean this again for simplicity. It's a lot of lines and you have to work with a pencil. Look at what we have. I've got this triangle here. Now I know that this, alright, I know that this is equal to that because we said B is the midpoint, alright, and I know that this is also equal to that, and I know, okay, since this is equal to that, this is equal to that, automatically this now will be parallel to that midpoint again, and this is half of this. I hope all my reasons make sense. Let's write all those reasons to that point. Alright, so M is the midpoint of PR, is that okay? And we have B as the midpoint as well. Therefore, can we say that MB is equal to half? Alright, either you use that half QA, we can use half QA. I hope that makes sense. M is the midpoint. Okay, I'm using different lines. M is the midpoint. Oh, you can also use that. Beautiful. Look at this. You can also use this. It's the same thing. Exactly the same. Okay, so M is the midpoint of PR. Alright. And B is the midpoint of PQ. Automatically we know that these lines are parallel, so it makes a lot of sense to go either way. Alright, so MB is half of QR. Ah, I like that. MB is half of QR. But what is QR in itself? What is QR? Do you remember that we've proven that this and this are equal? Alright? So, can we then say, look at, let me do it on the side. Let me write midpoint theorem here. Midpoint theorem. Our answer has AR in it. Check this. AR is actually equal, the full length here is equal to AQ plus QR. Is that fine? But AQ and QR are equal. So can I say AR, because I have QR there, QR plus QR. So what is AR? AR equals to 2QR. What is my QR? QR, divide both sides by 2, AR over 2. I hope that makes sense to us. So can I come back here and say MB equals to 1 over 2? Instead of writing QR, can I then write AR over 2? So what do I have? MB equals to AR over 4. Cross multiply. What do you have? AR equals to 4 MB. I hope that makes sense now. Alright, so you've got to learn to work out a whole lot of things. Euclidean, you have to practice. It's more about saying, and you have to draw your lines. Use a pencil, draw the lines, and you will be able to find your answers. I hope that's okay so far. Alright, let's go look at the other question. I think we have 2 more questions to look at.